Hello everyone, welcome back. In this video, I am going to discuss the various most important laws of mechanics such as Newton's 3 laws of motion, Newton's law of gravitation, parallelogram law of forces, triangle law of forces, Lami's theorem and principles of transmissibility of forces. Engineering mechanics is formulated on the basis of Newton's 3 laws of motion, and the validity of these laws is based on experimental observation. That means these laws are not proved based on the mathematical proof. However, they are verified with the help of experimental observation. Newton's first law. Newton's first law says every body continues in a state of rest or of uniform motion in a straight line unless it is compelled to change that state by a force imposed on the body, which means unless otherwise any other force acting on a body, the state of the body remains same. If the body is at rest, it will remain at rest. If the body is in motion, it remains in motion. This Newton's first law helps us to define what is force. Any agent which changes the state of the body is known as a force. For simplicity, we can classify forces into two categories: contact forces and non-contact forces. As the name implies, contact forces occurs when two bodies are in physical contact. Contact forces are tension forces, compression forces, normal forces, friction forces, spring forces, air resistance forces, and any applied force. Non-contact forces are weight, which is a gravitational force, electric force, magnetic force, strong nuclear force, and weak nuclear force. These non-contact forces play an important role in quantum mechanics. We don't deal these forces in engineering mechanics as we are dealing with Newtonian mechanics. Newtonian mechanics, also known as classical mechanics. Let us talk a little bit more about forces. If I apply a force on the wall, what happens? You can see I am applying a force, but there is no visible change in the wall. Wall is not moving and it is staying where it was. So what's happening? The force that I am applying is being resisted by the wall, and that's why the wall is not moving. This resistance force or the reaction force is equal and opposite to the force that I am applying. So there are two forces here: the force that I am applying, the reaction force from the wall. So we can say force does not exist alone. Forces always occurs in pairs. Now let's move on to the next law, Newton's second law. This Newton's second law helps us to quantify the force acting on a body. So the first law helps us to define a force. The second law helps us to quantify the force. This second law says that the acceleration of a given particle is directly proportional to the impressed force, and that acceleration takes place in the direction of a straight line in which the force is impressed. Newton's third law. To every action there is an equal and opposite reaction. Newton's law of gravitation. When two particles are attracted towards each other with a force along the line connecting them, then the magnitude of the force is directly proportional to the product of their masses and inversely proportional to the square of the distance between the two masses. So r is the distance between the two masses, and g is nothing but the gravitational constant. Lami's theorem. This Lami's theorem can be used to solve a physical problem which involves only three forces, and under the action of three forces the body should be in equilibrium. This is a limitation of Lami's theorem. So it can be applied only for equilibrium problems, and number of forces acting on a particle are only three, and all the three forces need to be meet at a common point. That is, these three forces need to be a concurrent force. So this states that if three forces F1, F2, F3 are acting on a particle and the particle are in equilibrium, then each force is directly proportional to the sine of the angle included between the other two forces. That is given by this equation, F1 upon sine alpha equal to F2 upon sine beta equal to F3 upon sine gamma. Parallelogram law. This parallelogram law helps us to determine the resultant of two concurrent forces, which says that if two forces acting at a point are represented by the sides of the parallelograms, then the diagonal passing through the point of intersection represents the resultant both in magnitude and directions. The resultant of these two forces is given by this formula, and the angle between the resultant and the horizontal force is given by this formula, where alpha is the angle between the two forces and theta is the angle between the horizontal force and the resultant. Triangle law of forces. This law also helps us to determine the resultant of two concurrent forces. It states that if two forces acting at a point are represented by the two sides of the triangle taken in order, then the resultant is represented by the third side taken in opposite order. Principles of transmissibility of forces. This law helps us to transfer a force from one point to another point, but in the same line of action. It states the condition of equilibrium or motion of a rigid body will remain unchanged if the point of application of a force acting on a rigid body is transmitted to act at any other point along its line of action, which means in this body a force F is acting at this point here. This force can be transmitted to act some other point here, but the line of action of the force should lie on the same line. This is the condition. Thank you.